Hey guys, welcome again to Fun with Nuts. In this video, we are going to solve another problem that is square root of m to the power of x plus square root of n to the power of x is equal to 13. M to the power of x minus n to the power of x is equal to 13. What is the value of x, m, and n? So here's the solution. By the way, this is our first equation and this is our second equation. Now, let's bring down our second equation. M to the power of x minus n to the power of x is equal to 13. Next is, let's follow this power rule. We have square root of a whole to the power of 2. That is also equal to a because the square and the radical can be cancelled. So the remaining is a. So for this, let's take a look. We have m to the power of x minus n to the power of x. We can write it as, for m, square root of m whole to the power of 2, then whole to the power of x, and then minus square root of n to the power of 2, then whole to the power of x equals 13. Next is, we can interchange the power by following this rule of a power. We have a to the power of m whole to the power of n, which is also equal to a to the power of n whole to the power of m. So as you observe, we can interchange our power. So for this, we can write it as square root of m to the power of x, then whole to the power of 2, minus square root of n to the power of x, then whole to the power of 2 equals 13. Next is another rule of a power. We have nth root of a whole to the power of m is also equal to nth root of a to the power of m. So for this, we can write it as square root of m to the power of x whole to the power of 2 minus square root of n to the power of x whole to the power of 2 equals 13. Next is, we can let a be equal to square root of m to the power of x and b equal to square root of n to the power of x. Therefore, this equation, we can write it as a squared minus b squared equals 13. And then to continue, a squared minus b squared is equal to 13. For this left side, we can write this in terms of identity. And this is a plus b times a minus b equals 13. Now for this, we can say that one of our equation is a plus b is equal to 13. So for this, we can now write it as 13 times a minus b equals 13 in replace of 13 from a plus b. Next, we can divide both sides by 13. So this is cancelled and this is equal to 1. So this is now a minus b is equal to 1. And for our equation, a plus b is equal to 13, we can add into a minus b equals 1. So plus a plus b equals 13. A plus a, that is 2a. Negative b plus b, this is cancelled, equivalent to 0. Equals 1 plus 13, that is 14. Now, we can divide both sides by 2. So this is cancelled. So we're left with a equals 14 divided by 2, that is 7. So a is equal to 7. Now, going back to this equation, we have a plus b equals 13. We can use this to get the value of b. So a is equal to 7. Therefore, we can write 7 plus b equals 13. And then, we can take 7 to the other side. So the left side, we're left with b. b equals 13 minus 7. And that is b equals 13 minus 7, that is 6. So we have the value for b, which is 6. A is equal to 7, b is equal to 6. Now, since we have the value for a and b, which is 7 and 6, let's recall that earlier we let a be equal to square root of m to the power of x, and b be equal to square root of n to the power of x. So for a, That is a equals square root of m to the power of x. For this, we replace with 7. So 7 equals square root of m to the power of x. For this, let's remove the radical by squaring both sides. So now this is cancelled. We're left with 7 squared, that is 49, equals m to the power of x. Now, if you observe, this side have a power and this side has no power. So we need to change 49 back to a power form, and that is 7 squared. So 7 squared equals m to the power of x. Or using the commutative property, this is now m to the power of x is equal to 7 squared. Now next is for the value of b, and earlier we let b be equal to square root of n to the power of x. So b equals square root of n to the power of x. b is equal to 6. 6 equals square root of n to the power of x. Now same, we need to square both sides, so that we can cancel this squared and the radical. So we're left with 6 squared, so we don't need to write it into a whole number. Just write 6 squared equals n to the power of x. Or using the commutative property, that is n to the power of x equals 6 squared. Now for this, using the comparison, if we compare, the power of this side is x and 2. And this side, the power is also x and 2. That means x is equal to 2. And then we have m is equal to 7. And then n is equal to 6. So these are the values of x, m, and n. Again, x is equal to 2, m is equal to 7, and n is equal to 6. And that's all for today. For more exciting videos, don't forget to like and subscribe to Fun with Maths.